Hello again, my favorite first block class. How are things going? Hopefully you're still safe and getting enough rest and eating properly and all that kind of stuff. It did occur to me last night that there are some problems that we didn't go over in the last video. And that was namely the ones that you have to use trigonometry to solve. And trigonometry is a word that, kind of scares a few people, but this is simple trig, and it's nothing to concern yourself about. All you need is one of these, okay? And let's see how a problem would work here if we were needing to use trigonometry. Okay, so let me put my word here and focus on it. And there we go. All right. So we learned on the video I posted yesterday that work is equal to force times distance. And if we concentrate on that particular formula, we can expand our knowledge to incorporate problems where we might be pushing something at an angle. Okay, so if we look at that angle a little bit more, let's say that it is a 25-degree angle. Okay. And we are pushing this lawnmower or this cart or whatever, stroller, all of the, those types of situations would fall into this category. And we're pushing on this handle here. Here we are. Let's make us a little bit taller than that. Okay, we've been so cooped up. We've grown a lot of hair, and we are pushing the best we can when we're made to get outside and do work. And this is a ponytail. You've grown so much hair, can't get it cut. So, now you're outside and it's hot, and you need to put it up in a ponytail to keep it off your neck. And so we're pushing this lawnmower. It could be a Briggs and Stratton engine. And for those of you who know what I'm talking about there, it's about the only kind you can buy nowadays. If you're buying regular lawnmowers, I think I'll just take that off. All right, so we're pushing along this handle here with, let's say, 200 newtons of force. So how is this lawnmower being pushed along the ground? How much, or how, what is actually doing the work here? All right, so if we think about trig for a second, this angle 25 degrees, if we set it up to solve, and I think I've asked most of you if you've had some simple trigonometry before, and most of you have. So I'm relying on that to move forward with this little demonstration. So we're pushing this handle here with 200 newtons of force. That 200 newtons of force is actually being split up into a vertical force and a horizontal force, like so. And so we're not actually pushing the lawnmower with 200 newtons of force. We're pushing the lawnmower with whatever force is along this line right here, because that is the direction the lawnmower is going. It is parallel or on the same plane as the lawnmower. So it's going in that particular direction right there. All right. And this, without realizing it, when we push the lawnmower, we're actually trying to push it into the ground with a certain amount of that force. So that force is split up into a part that basically is being wasted when you push down on the handle here. When you're pushing the handle across this way, you're actually pushing some of it down this way and then some of it this way. But this is the force we're concerned with. If we want to find out how much work is being done, this is the force we need to solve for using trig. And then we can see that if we consider this angle, the side that's opposite that angle there is this one. And then the side that is adjacent to the angle is this one. So from our studies of simple trigonometry, we know that we can solve for cosine of 25 here. Cosine of 25 degrees. Okay, and so the cosine of an angle, here's the formula that you can put on your formula sheet. And usually we use the symbol theta, the Greek letter theta, for just any given angle. It's equal to the adjacent side divided by the hypotenuse. Okay, so this is the hypotenuse because it's the line opposite the right angle that's being made here with the ground. So in our situation, the adjacent side is what we're looking for. And so we'll call this the force horizontal, F sub H. And then this one is F sub V for vertical. All right, so we can say then that F sub H would be equal to the horizontal force divided by the hypotenuse, which is 200 newtons. Okay, now I have a TI-89 here, which is pretty cool. It's also outdated. But anyway, I'm going to go in here, and you need to do this too. You need to find the mode button on whatever calculator you're using. And let's see if I can get in here and see this. Okay, you need to find the mode button and push it. And then we need to go down to angle and make sure that this thing reads degree. Okay, some of your math teachers use radians there, but in physics and physical science, we use degrees. Okay, and that's sort of important because anybody who aspires to be a pilot or in some sort of role as a navigator would have to use degrees on maps and in computers. All right, but for our case, we need to make sure we get the right answer. And so we want to make sure that that angle mode there is in degrees. And so since it is, I'm going to get out of it now and work my problem. Here's a problem that we worked last night when we made that video. So I'm going to say shift here, this little second, and then I'm going to find the cosine, and here's the cosine right there, which is on the button marked Z on my calculator. But I'm matching the blue color here with the blue cosine on the board, and so I've hit second, and you can see the second has shown up down here, and it's showing me that I'm in degrees as well, and that I'm in the approximate answer mode, which is something else. But here we go. So I'm going to press cosine, press the Z, and so it opens up this little parentheses here, and I'm going to plug in 25 because that is our angle. All right. And then doing a little algebra, let's go back down a little bit here. Doing a little algebra, I'm going to multiply both sides by 200. And that's going to move the 200 over here to this side. So it'll be cosine of 25 degrees times 200 newtons. And that's going to give me the answer that I'm looking for, the horizontal force. Okay. So then I go back to my calculator, and let's raise it up a little bit again. And I'm going to put in 200 because that's my hypotenuse. And notice I close the angle there in parentheses. You have to close that angle once you put it in. And then now just putting it next to the cosine of 25 is going to give me multiplication. So I'll press equals, and you can see, and you've used calculators before, of course, that little dot tells me that it understood that I needed to multiply 200 times the cosine of 25. All right, so my answer, and we're rounding things off to 2 places past the decimal, so my answer for this is 181.26 newtons. And that is the force that's actually doing the work to push this lawnmower across the yard. All right, so now how much work is being done? Well, how far did we push? Now that we know the force, how far did we push the lawnmower? And let's say we pushed the lawnmower 10 meters in this direction across the yard. And so now we say work is equal to the force times the distance. So we use our 181.26, and that's a little sloppy. 181.26 newtons times my 10 meters that I pushed it. And so we end up doing this much work, 1012.6 Newton meters, or, yes, joule. I hear somebody thinking joule there. And yes, that's the SI unit for work and energy at the same time. All right, now, if the nice thing about this is not very smart, but sometimes we are tempted and actually do this. You're not ever supposed to pull a lawnmower. because you run the danger of slipping and maybe the lawnmower ends up on top of you. But if we were to pull this lawnmower, we would have exactly the same problem. 25 degrees. Okay, and so now we're pulling in this direction, and whatever force we're using this time, maybe we get by with 175 newtons. Maybe it's a little easier to pull. And so how much work are we doing for the same 10 meter stretch? Well, it's the same problem again. Cosine of 25 equals, we want that horizontal force, which is going in this direction now. Okay, we're pulling along the handle in that direction. And this time, instead of pushing the lawnmower into the ground, we're trying to pull it off the ground. And so you can't really work one of these problems or work one of these things in the yard. You can't really do this task without wasting some of your energy. We can't, for some reason, it seems, trust the earth to hold on to that lawnmower. We think we have to push it into the ground. But then, for some reason, we want to try to lift it off the ground when we go back the other direction. So once again, we have force horizontal over, this time, 175 newtons is the force we're using. Okay, so I'm going to go ahead and multiply both sides by 175. And I end up with the horizontal force. It's supposed to be an S there. Okay, the horizontal force is equal to the cosine of 25 degrees, if you can read that, times 175. Okay, so back to the problem here. Back to the calculator. Zoom in. For some reason, it's not zooming for me. Okay, well, if I push the right button, maybe it would zoom. All right, so now we have same cosine. So I'm gonna hit second and cosine again, right there. And this opens up that parentheses. I'm gonna put in our angle, close the parentheses. And now I'm going to multiply it right here times 175. Now this time I put in the multiplication symbol. Didn't really have to do that. Sometimes it's just a force of habit. And I'm going to hit equals. And this time I'm doing this much work. But you can't see. Okay, so this time I'm doing this much work, and I'm going to go ahead and put joules here. All right. So there we go with trig and problems. And now I'm going to do one more, and so that I can let you pause and work the problem. Okay. So here is, maybe this is a aerator, one of those aerators. I call them lawn rollers. And you're pushing it across the yard. You're not too happy about it. It's got these spikes in it. You're pulling plugs out of the ground. Some sort of frame that lets you do that. Okay, so here is the same situation. Okay, now, what I want you to do on this video is I want you to solve for the problem, or practice doing the problem. And so when you get to the point where you see what the problem is, pause the video, see if you can work the problem, and then watch me do it. See if you can get the same answer I do. All right. All right, so this time we're pushing, let's say with, this is a little heavier, so we have to work a little harder. 250 newtons of force. We're going to push it along the same 10 meters. Okay, and this one has an angle of 32 degrees. 32 degrees. Okay, so I'll put 32 here. So I didn't do a very good job of writing that. Okay, so here, I'm going to give us one more little problem to do. First of all, I want to know how much horizontal force is being used. This one right here, to push the lawn roller across the room or across the yard. All right, and then I want to know how much force we're wasting this time by pushing the lawn roller into the ground. So this time we'll solve for two forces. And then, of course, our last thing, we want to know how much work is being done. Okay, so these are our three unknowns. Okay, and there we go. There are three unknowns. And so now you can solve the video, or excuse me, you can pause the video and solve for these three variables here, these three things that we don't know. And then you can start it back up and see how it works. All right, so pause. And we're back. Yes, that was very cleverly done. All right, so here we go. Let's make sure we've got the formulas for these things. Here's my horizontal. So I can use the horizontal cosine of 25 degrees is going to equal to the horizontal force over my hypotenuse again, which is 250 newtons. Okay. And I don't know if that's under the picture of me or not on my computer. It is, but that's F sub H over 250. All right, I guess you can move that picture around somewhere else. All right, and then once we solve for that, we're going to need to do the work with that particular answer. But here's another issue. I'm going to go back to trig for this and look at this right triangle again. And this time we're looking for the second answer. We're looking for the side that's opposite 32 degrees. And for that, we're going to use the sine of our 32 degree angle. Okay. And so it's located, sine is located on the board, just like cosine is. And so we're going to hit second and then sine when we get to that point. So this will be the sine of 25 degrees is equal to the vertical force over 250 newtons. Okay, and then we'll have for our work formula, force horizontal times the distance that we push it. So there's our three problem setups. And we'll get ready now, or we'll start by solving for the horizontal force. So let's come down here. Force horizontal is equal to, let's multiply both sides by 250. And that moves the 250 to the other side. like so. All right, and back to the calculator. And let's turn it on. Let's clear the last answer. So here we go with secant and cosine again. And that opens up that parentheses. And this time we're putting 25 degrees in. And then we're going to multiply it times our 250 is right here. And that's the one that's along the handle. And that gives us 226.58. 226.58. Okay, 226.58, and that's newtons. All right. Now, in physics, of course, we call these vectors. Vectors being a quantity that has a direction. So this would be 250 newtons would be our quantity. And the direction would be 32 degrees with the horizontal or the ground. So you probably might say horizontal, or it might say the ground. All right. So there's our first answer. Let's go to our second answer. And here we are over here, sine of 25. I keep leaving letters out. Okay, the sine of 25 degrees is equal to the force vertical over 250. So I'm going to multiply both sides by 250 again. And this time it's going to be the sine of 25 times the hypotenuse. Okay. And back to the calculator and back to our trig buttons. Clear that last answer. And here we go. The sine. Well, the sine hits second. And then hit sine right here. And we put in our 25 degree, 32 degree angle. And did I used 25 on the last one instead of 32. I just now noticed that. So I'm going to go back and redo this problem. I apologize for that. You're probably screaming at me, Mr. Buzz, are you using the wrong angle? But of course I can't hear you. All right. So let's try that again. Let's go back and do our cosine. Cosine 32 degrees. And we're going to multiply that times 250. And that gives us 212. And a couple places past the decimal, 0.01. Okay. So let's go with sine of 32. Okay, sine of 32. So let's put in second, and then hit the sine key, and that gives me the sine function there. And 32 degrees, let's close that parentheses. And now we'll say times 250, and we get 132.48 newtons. And, you know, you can look at these vectors and wonder, you know, what's going on mathematically here. But vector addition doesn't work exactly like regular addition. So there might be some strange things there that you're noticing, but that's to be expected. And just know that when you're adding vectors to come up with a sum, they don't always work the way you want them to or the way you think they should work. All right, and I'll put in, when I send this video out, I'll put in that I used the wrong angle and then I'll correct it later on in the problem, so maybe you won't be screaming at the screen after all. Okay, so we have one more problem to do here. We've got to solve for the work that's done. And so we have work equals force times distance. And we have two forces here, but we're going to use the one that's actually doing the work, and that's the one that's going horizontal. Okay. All right, so my horizontal force, and make sure I get the right one. It's easy to go back up if you're not paying attention and pull up the wrong one. So there is my force. We're using that same 10-meter stretch. And that makes for an easy problem, of course, an easy answer. And we end up with our final answer here. And let's see if I can do that correctly. Move a decimal point over one place, and that's going to be Newton meters or joules. So there's my three answers. Now you have the video that you need for those other kind of problems, which I neglected to put in the last video, but maybe that broke it up for you some and you won't have to watch one single video that's really, really long. But this should get you through that first worksheet, and then we'll start thinking about a little quiz that we'll do online where you can fill it in and just basically set up the work similar to the way you did the worksheet, and then I'll check it going in to see who's done their work and so forth. All right, so once again, our word, our special word here that we are creating, combination of stay safe, Stafe. All right. See you next time. And maybe I'll see if I can figure out a way to get in a little music in the background here, maybe some Jimi Hendrix, you know, or something like that. So we will piddle around here until we get this video to stop. And this should stop. No. All right. So here we go. Stop sharing. That got rid of the camera. And now let's do